Hi, this is Dylan, and I'm doing a tutorial on how to solve one of the review problems. And the problem is the integral of tangent to the fifth theta multiplied by secant to the third theta d theta. Now, how you want to start this problem is because you have tangent raised to an odd power and secant raised to an odd power. That means you're going to want to pull out a factor of tangent and then make a substitution. So this is going to equal the integral of tangent theta multiplied by tangent to the fourth theta secant to the third theta d theta. And the substitution you're going to be making is tangent squared theta plus 1 equals secant squared theta. So that means tangent squared theta equals secant squared theta minus 1. So this is what you're going to be plugging into there. So you have the integral of tangent theta multiplied by this right here, secant squared theta minus 1. And because this is to the fourth, you're going to have to square this. And it's multiplied by secant to the third theta d theta. After doing this, you need to make a u substitution for secant theta. So u equals secant theta, and you take the derivative of this. So this will become du equals secant theta tangent theta d theta. And then you're going to divide this by 1. So you have 1 du all over secant theta tangent theta equals d theta. So this right here is your u substitution, and you're going to be plugging this in for d theta. So you have the integral of tangent theta multiplied by this will actually become u squared because u equals secant theta minus 1 squared multiplied by u to the third all over secant theta, which will be u, times tangent theta multiplied by du. So this is it. And now some of these can cancel out. You see the tangents here. You can cross these out. And you also have a u on the bottom and a u to the third, so this becomes squared, and this u is gone. So now you're left with the integral of u squared minus 1 squared times u squared. And now you want to take this right here, and you gotta factor it out. So you got u squared minus 1 times u squared minus 1. So you're gonna multiply these together. So it's u to the fourth, this times this, minus u squared plus 1, which equals u to the fourth minus 2u squared plus 1. So this is the integral of u to the fourth minus 2u squared plus 1 times u squared. So you're going to take this u squared and multiply it out through this. And when you're multiplying something with an exponent in it, and you're putting this together, you're adding the exponents. So this equals the integral of u to the 6 minus 2u to the fourth plus u squared. Alright, now we're finally at the point where we're going to need to take the integral. So what you want to do is split this up into 3 different parts, because you have subtraction and addition in this. So this equals the integral of u to the 6 minus the integral of u to the fourth. You can pull out this too because you're not going to be taking the integral of that. That's just a number. Plus the integral of u squared. So when you're taking the integral of something, the rule is it is x to the n plus 1 over n plus 1. So for this u to the 6th, this will become a u to the 7th because you're adding 1 to it, and then you divide that by 6 plus 1, so 7. And then this will become 2 multiplied by, you have u to the 4th, add 1, u to the 5th, divided by 5, plus u to the 3rd, divided by 3. Now that we have it like this, we're going to be able to take our u substitution and plug it back in. So this is secant theta to the 7th over 7 minus 2 secant to the 5th theta over 5 plus secant to the 3rd theta over 3. And when you take the integral of an indefinite integral, you're going to be adding c at the end of this. So you always want to add a plus c for any number that can be on the back end of this. And this here is your answer.